Hi, welcome to the Olympiad Geometry Club. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. Today we're going to continue our study on the geometry treasure, the generalization of sine law. Basically, we will have maybe 2 or 3 videos talk about the generalization of the sine law. This is the first video, which is just some generalization on different centers. Okay, theorem 1. In an oblique triangle ABC, R is the radius of its circumcircle, AD, BE, CF are the altitudes, DEF are the phi, H is the orthocenter. Then we have several properties that we want to prove. Okay, so the first thing, let's just draw the figure. We know we are talking about the triangle, which also relate to the radius of the circumcircle, so we can just draw the circumcircle. And draw the triangle. We know it's A, B, C here. Circumcenter O. Now, AD, BE, CF are the altitudes. So, AD BE and CF are altitudes. Actually, H is orthocenter. Then AH to absolute cosine A equals 2, BH to absolute cosine B equals 2, CH to absolute cosine C equals 2, 2R. We just need to prove 1, right? Let's try to prove AH to absolute cosine A equals 2, 2R. If you remember that actually this one we already proved it before, but let's just do this way. We can connect BO and extend it. Meet the circle O on a point. Let's call it. Let's call it K. Okay. So we can connect CK. We know that BK is a diameter, so angle BCK is 90 degrees. Which means CK is perpendicular to BC, which means CK is in parallel with AH. Right? And because BK is a diameter, we know that angle BAK equals to 90 degrees. So we know AK is perpendicular to AB, which means AK is in parallel with CH, which means AKCH is a parallelogram. And based on that, we know AH equals to CK. CK equals 2, because triangle BCK is a right triangle, CK equals 2, BK times cosine angle BKC, which means BK is 2R times cosine angle BKC equals to cosine angle BAC, which is cosine angle A. So we know that AH divided by cosine angle A equals to 2R. Right? The reason we have absolute sign here is because we can, the angle A can be acute angle or obtuse angle, so that's for obtuse angle case. The second one, we want to prove that dh to cosine B cosine C equals to EH to cosine C cosine A equals to FH to cosine A cosine B equals to 2R. So basically we want to find the relationship between dh and 2R, right? dh and 2R. Just look at this one. If we use 2R times cosine B, that is BH, which means we just need to prove dh to cosine C equals to BH, right? dh to BH equals to cosine C, which means we just need to prove that this angle is cosine C, which is obvious because angle HEC is 90 degree, angle HDC is 90 degree. That means HDCE are cyclic, which means angle BHD equals to angle ECD. That means angle BHD equals to angle C. So angle BHD equals to angle C. Then we know that HD to BH equals to cosine angle C, right? It's a straightforward proof. Okay. And now let's look at the third one, which is EF to sine A cosine A equals to 2R. We know 2R times cosine A, that is AH. So we just need to prove EF to sine A equals to AH. Right, basically we just need to prove this one. EF to sine A equals to AH. And now let's think about EF. EF is here and AH is here. So in the triangle AFE, right, in the triangle AFE, we know that EF to sine A equals to AF to sine angle AEF, right? That's a sine law for the triangle AFE. EF to sine angle A equals to AF to sine angle AEF. And because AEHF are cyclic, so we know that angle AEF equals to angle AHF. So this one can be rewritten as AF to sine angle AHF, right? Because angle AEF equals to AHF. Then in the triangle AFH, which is a right triangle, we know that AF to sine angle AHF equals to AH to sine angle AFH equals to AH, because angle AFH is 90 degrees, so this is 1. Then we get that EF to sine angle A equals to AH. We just prove that. Okay, that's the third one. And for the fourth one, we want to prove, let me write it here, AH times BH divided by FH equals to 2R. Okay, so we already know that we want to calculate for FH and we want to calculate for the 2r. So let's rewrite this one. It's AH times BH equals to 2r times FH. And we know that AH times BH can be rewritten as 2r cosine A times 2r cosine B. We want to prove it equals to 2r FH. Basically, we want to prove that 2r cosine A times cosine B equals to FH. And we know that 2r cosine A equals to AH. So AH cosine B equals to FH. AH cosine B equals to FH. Basically, we just need to prove that this angle equals to angle B, which is obvious because the angle BAD plus angle ABD is 90 degrees, and angle BAD plus angle FHA is 90 degrees. So angle FHA equals to angle B. So we know that AH times cosine angle FHA equals to FH, and this one can be derived to here, right? This one is valid, so we know that this is valid, and all the way back, we know this is true. Okay, next one. Looks like I need paper. Okay, let's do it here. Next one, we want to prove AB times CH divided by DE equals to 2R. What we get before? The DE equals to 2R sine C cosine C, right? And AB can be rewritten as 2R sine C. So basically we want to prove that 2R sine C times CH equals to 2R times 2R times sine C times cosine C, right? Basically we want to prove that CH equals to 2R times cosine C, which we already proved that in the first one. So it's obviously valid. Let's see the fifth one. Actually sixth one, that's AB times AC divided by AD equals to 2R. Okay. So what is AB times AC? AB times AC, we can assign another one. So the AB times AC remind us the area of the triangle ABC, which means that we can write AB and AC as twice of the triangle area divided by sine angle A, right? AB times AC equals to this one. Twice of the area divided by sine angle A. So let's look at 2R times AD. 2R times sine A equals to BC, right? And BC times, so 2R times sine A times, which is BC times AD. That is BC times AD, that is twice of the area triangle ABC. So we know this is obviously valid, right? Because this one can be rewritten as 2R sine A AD divided by sine A, which equals to 2R AD. Okay, now we get that AB times AC equals to 2R times AD. Okay, that's sixth one. And then the seventh one, AD divided by sine B sine C equals to 2R. Okay, AD divided by sine B sine C equals to 2R. This is obvious. AD divided by sine C, which is AC. Right? AC equals to 2R times sine B. So this is true. Those are the generalization of the sine law of, let's call it for the auxiliary center. Now let's look at the centroid. Theorem 2. Let G be the centroid of triangle ABC. Then we have some more results. Let's write it here. Okay, because we'll calculate for the centroid, let's redraw the figure. The midpoint. Right, this is a centroid G. Now we see that GD, GE, GF are the distance from G to BC, CA, AB. So this is GD, GE, GF. Right, we want to calculate for GD divided by sine B sine C equals to 223R. We can see that GD, so the break point here is on 3, right? 3 just remind us we need to find the altitude of the triangle ABC, so let's call this point as T. We know that GD to AT equals to 1, 2, 3, which means GD can be rewritten as 1/3 of AT. So we can try to prove that 1/3 of AT divided by sine B sine C equals to 223R. Right? Which means we just need to prove that AT to sine B sine C equals to 2R. And we already know that we proved this before, right? If you look at here, AD is the altitude, which is AT, we write here. AD to sine B sine C equals to 2R, and we want to prove that AT to sine B sine C equals to 2R. We already done that, right? So this is true, which means that this is true. And the second one, MA, MB, and MC are the median of triangle ABC. So here, AM is MA, is a median of triangle ABC. We want to prove that MA to half of square root 2 sine square B plus 2 sine square C minus sine square A equals to 2R. What says? What says? We can directly recognize the sine square B or sine B times R that relate to the AC, and the sine C times R relate to the AB, and sine A times R relate to the BC, right? And we have this square plus square minus another square thing that remind us the Stewart theorem, right? So let's just write it. You remember the stood theorem in the median? We can have a simplification case, but let's just review it. A, B, C, right? AM is a median. So we know for the stood theorem, AM squared equals to AB squared times MC2BC plus AC squared times BM2BC minus BC squared times BM2BC times MC2BC. Right? When M is a midpoint of the BC, we know that this one can be written as half of AB squared plus half of AC squared minus 1/4 of BC squared. Right? Which is half, actually 1/4 of AB squared plus AC squared minus BC squared. Right? And what is AB? AB equals to 2R sine C, and AC equals to 2R sine B. BC is 2R. Wait, here I did something wrong. Twice, right? That's correct. 2R BC equals to 2R sine A. So we can replace all of this into the equation above. We got AM squared, which is MA squared, equals to 124 twice of 2R sine C squared plus twice of 2R sine B squared minus 2R sine A squared. Right? So we can extract 2R out. We got 124 times 2R squared times 2 sine squared B plus 2 sine squared C minus sine squared A. So we get MA divided by 1/2 of squat this thing here equals to 2R. Right, we just proved that this equation is valid. Okay, that's theorem 2. Let's talk about theorem 3. Theorem 3. O is the circumcenter of triangle ABC. Then we have some okay. OD, OE, OF are the distance from O to BC, CA, AB. So this is D. This is E. This is F. And we know that D, E, F are the midpoint of BC, CA, AB respectively. We want to prove that OD to cosine A equals to R. Right, what is OD? OD is this one. And if we connect BO We know that BO is R and angle BOD is angle A. So OD to cosine A is R. It's obvious. True. The second one, AOBOCO meets the opposite side on A1B1 C1 respectively. So we have AO, connect AO and extend AO to here. This one is A1. And we want to prove that AA1 2 sine B sine C second B minus C equals to 2R. Basically, we want to prove that AA1 cosine B minus C 2 sine B sine C equals to 2R. Right? And remember this, 2R times sine B sine C equals to AD. What is AD? AD is the altitude on BC. So for here, we want to prove AA1 cosine B minus C equals to 2R sine B sine C, which is AD. And I write it as 80, so let's actually give it a new name, call it AK. Okay, AK here is altitude. We know that 2R times sine B sine C is AK, so we want to prove that AA1 times the cosine angle B minus C equals to AK. Basically, we just need to prove that angle A1 AK is angle B minus C or angle C minus B, right? So now let's look at the angle A1 AK. Notice that this is the angle OBA is half of angle B, right? This is half of angle B. And OB equals to OA, so this is half of angle B. And what is this? This one is 90 degree minus angle C. Then what is angle A1 AK? It's angle A minus half of angle B minus 90 degree minus angle C, which equals to angle A minus half of angle B minus half of angle A plus half of angle B plus half of angle C minus angle C. So A equals to half of angle A, right? And we have minus and half of angle B plus, actually minus it's half of angle A minus half of angle B minus half of angle B. That's minus angle B. And then this is minus half of angle C, so plus half of angle C. Wait, did I do something wrong? Angle A minus half of angle B minus 90 degree minus angle C, right? So that's sine. Actually, it's 90 degree plus angle A minus half of angle B. No, it's negative, right? And plus angle C. which is I feel there's something wrong, but let me think, which is angle A plus angle C plus angle B minus angle B minus 90 degree minus half of angle B. Right, so this is 180 degree equals to 90 degree minus B minus half of angle B. Wait, something wrong. Let's review again. So first, 2r times the sine C sine B equals to the altitude AK. That's fine. And now we want to prove that AA1 times cosine B minus C equals to AK. So this angle must be angle B minus C. Basically, we just want to prove that angle A1AK equals to angle B minus angle C. Right? Oh, I see the problem. I see the problem. This is not half of angle B, right? Because this is a connection of BO. It's not the angle bisector. So this is not half of angle B. Okay, that's a mistake I made. The angle for this one, we should calculate as this way. The angle A1AK equals to 90 degree minus angle AA1K. Right? This one equals to 90 degree minus this angle. And this angle is the angle AA1K equals to angle B plus this one. And what is this one? This one is half of angle C, right? I mean 90 degree minus angle C. So plus 90 degree minus angle C. Which means angle A1AK equals to 90 degree minus angle B minus 90 degree minus angle C, which equals to angle C minus angle B. Right, I just made a mistake that BO connection here is not angle bisector, just the figure. Anyway, okay, we just proved that this is valid, and for the rest of the part it's the same. Now let's look at the theorem 4. Theorem 4. Let I be the incenter of triangle ABC, and we want to calculate for IA divided by sine half of angle B sine half of angle C equals to 4R. So now we have, still I want to draw the circumcircle. And now we have angle bisector. I is the incenter, so we want to find the angle bisectors. Because it's angle bisector, so we just need to find the midpoint of the arc BC and do the connection. Right? That's definitely the angle bisector, and also similar here. Okay. This is I, and we know this is O. Okay, now we want to prove that IA2 sine half of angle B sine half of angle C equals to 4R. First, we can think about IA divided by half of sine angle C equals to 4R times sine half of angle B, which is twice of 2R sine half of angle B. Right, this is angle B, and half of angle B is either this angle or this angle. Let's just call it DEF here. So sine angle 2R times sine half of angle B equals to AE or EC, right? So this part is AE or EC. Basically, we want to prove that AE or EC times sine half of sine angle C, no, sine half of angle C equals to IA. Right, so yeah, so we want to prove that IA divided by sine of half of angle C equals to 2 times AE. Now we need to think about where is half of sine half of angle C. It's either this one or this one. Right, and we need to relate IA and this angle. Now we can see IA divided by half sine half of angle C equals to AC divided by sine angle AIC. Right. What is sine angle AIC? Angle AIC equals to 180 degree minus half of angle A minus half of angle C equals to 90 degree plus half of angle B. Right, so it equals to AC divided by sine 90 degree plus angle B divided by 2. Right, it equals to AC to cosine half of angle B. Basically, we want to prove that AC to cosine half of angle B equals to 2AE. Right, we want to prove that twice of AE divided by this AC, twice AE equals to AC divided by twice of angle B. Right, and now we can just find the midpoint of AC, which is point called M. So we know that AC divided by 2 equals to AM. We want to prove that AM divided by AE equals to cosine half of angle B, which is obvious because angle EAC equals to angle EBC, which is half of angle B, right? And because M is a midpoint of AC, we know that EM is perpendicular to AC. E is a midpoint of arc AC, right? So EM is perpendicular to AC. So AM 2AE equals to cosine half of angle B. Now we just prove that all of these can be reversed, so it is true. Okay. And the next one, we want to prove that TATBTC as the angle bisector of triangle ABC. So which means from here to here, let's call this point as K now. So AK is the angle bisector, which is TA, the length is TA. TA divided by sine B sine C divided by cosine B minus C divided by 2 equals to 2R. So basically we just want to prove AK cosine B minus C divided by 2 equals to 2R sine B sine C. Right. What is 2R sine B sine C? We know it's altitude here. So let's call it S. So we want to prove AK cosine B minus C divided by 2 equals to AS. And if you look at the figure, basically we just need to prove that angle KAS equals to B minus C divided by 2. So what is angle KAS? It equals to 90 degree minus angle AKS equals to 90 degree minus angle B plus half of angle A, which is half of angle C minus half of angle B. So it's half of angle C minus B. Right? So we know that AS equals to AK cosine angle C minus angle B divided by 2. It's true. Okay, that's theorem 4. Theorem 5. Let IA be the eccentre of side BC, then we have this one. Okay, let's just draw the figure. IA, right? IA is eccentre of the side BC. Then we want to prove that AIA divided by cosine half of angle B cosine half of angle C equals to 4R. Okay. So first we need to find the half of angle B and half of angle C, because this is angle B, right? This is angle B. So this one is 180 degree minus angle B, and half of it, that is 90 degree minus half of angle B, right? So we can think about AIA, so because this is 90 degree minus half of angle B, so we know here is half of angle B. Similarly, this one is half of angle B. Right? So we want to find a way to correlate with cosine half of angle B, which we can just give a guess, right? Here, what we can find is, we have a 4R here. This 4R must relate to some side, either AB or BC or CA. And we have AIA here. We know that AIA equals to this one, let's call it RA. AIA times sine half of angle A equals to RA. Right? AIA times sine half of angle A equals to RA. And we know that actually, you know what? Let's just redraw the figure. I want to have the circumcircle. That makes everything easier to think about. I don't want to do a hard calculation here. Okay. Now let's review this one. So first we have the triangle ABC and its circumcircle, and now we want to find the X circle, which we just need to find the angle bisector here and here, right? So let's call it IA. And we know that AIA is also the angle bisector of angle BAC. Great. Now it's easier to think about the figure. Still, we just want to find the relation